In the coming lectures, we are going to talk about optional. So first of all, what is the optional class? Java 8 has introduced a new class optional in the java.util package. It is a public final class and used to deal with null pointer exceptions, which can crash your code at runtime, and it is very hard to avoid without using too many null checks. So it is a wrapper class that contains an optional value, meaning it can either contain a given object or a null value or an empty value. Therefore, it is possible to manipulate null values as if they were normal instances without necessarily having to perform a null check at every single step. So the optional car may contain a null value, it is called an empty optional, or it may contain a given object. In this case, the optional contains an object of type car. Okay, so the optional class includes various utility methods to explicitly deal with the cases where a value is present or absent. However, the advantage compared to null references is that the optional class forces you to think about the case when the value is not present. As a consequence, you can prevent unintended null pointer exceptions, which is quite useful. It is important to know that the intention of the optional class is not to replace every single null reference. Instead, its purpose is to help design more comprehensive code so that by just reading the signature of a method, you can tell whether you can expect an optional value. This forces you to actively unwrap an optional to deal with the absence of a given value. Okay, so let's take a look at a concrete example of creating optional object. We can create an empty optional like this. Optional type car is equals to optional.empty. This is how we create an empty optional, and we are able to instantiate a new car class, and we have the instantiated object, and with the help of the optional.off nullable, and we provide the car as the parameter, we can create an optional with not null value. By the way, the off nullable method ensures that if the car was a null, then the result would be an empty optional instead of a null. For example, if a value is present in an optional container object, then the isPresent method will return true and the get method will return the value itself. Additional methods that depend on the presence or absence of a contained value are provided as well, such as the or-else method that returns a default value if the value is not present, and the if-present method that executes a block of code if the value is present. So this is why this optional wrapper class is extremely useful in order to avoid null pointer exceptions. In the next lectures, we are going to take a look at concrete examples, and it's going to be clear how to use optional class. Thanks for watching. In this lecture, we are going to talk about how to use the optional wrapper class. So first of all, let's create a new person class. So person. The person is going to have one single instance variable, the private string name. In the constructor, we can initialize the value of the name. So I use something like this, string name. So this dot name is equals to the name. I'm going to override the toString method, and we just return with this dot name. And I'm going to generate getters and setters. So source generate getters and setters for the name variable. Basically, we have two methods, public string get name that returns the name itself, so this dot name, and the set name that gets a name parameter and update the value of the name. Okay, so this is the class we are going to use. Okay, and in the main method, we are going to instantiate a new person class. So person with the name Kevin Smith, and we can create an optional with the help of optional, and we have to define that it is going to store a person object. It is going to be a person. At the beginning, it's the person empty, so we can use something like this. Optional java.util, as you can see, this is the package. Here we have to use something like the empty method. So if we use something like this, this is how we can create an empty optional. So what does it mean exactly? That if we print out the person empty, we save it and run it, as you can see, it is the optional empty value. So this is how we can create an empty value instead of a null reference. And of course, we can use the of method. So if we use of the person, then this person, in this case person optional, is going to store the person object itself. So person optional, we can call the get method. With the help of the get method, as you can see, we can get the person object itself. So get method and get name, this is how we can get the person object with name Kevin Smith. So if I run it, then Kevin Smith is going to be printed out. By the way, if I print out the person optional itself, then the optional is going to be printed out like this, as you can see. So Kevin Smith is the value as far the optional is concerned, because with the help of the of method, it's going to return an optional with the specified person non-null value. So the person has the value Kevin Smith as the name, and this is why if we print out the optional that we have created based on the given object, this is why Kevin Smith is going to be the value of the optional itself. The main problem with this of method that if we specify a null object, so for example, if we set the person to be a null and here we define the person, then we are going to get an exception. So as you can see, null pointer exception, because the person is a null. So this is why this of method is not the best solution possible. We can check whether the optional contains a valid object or not with the help of the isPresent method. So we can use something like a new person Kevin Smith. Okay, we are going to create an optional of the person. By the way, let's talk about the better solution first. So instead of this of method, we can use the of nullable method that's going to take the same argument. So in this case, the person, and it is going to work fine. Why is it a better solution? Because if we define a null here, then there's not going to be any exception. As you can see, the optional empty is going to be the value of the optional itself. So this is why this of nullable is a better solution than using the of method exclusively. Okay, so if we use this of nullable, then we can check that if the person optional is present, this is present returns true if there is a value present, otherwise a false. So what does it mean? That we print out that there is a non-null object in the optional with value, and we can print out the value with the help of the person optional dot get. As you can see, the get method is going to return the value itself. So because in this case we store a person object, this is why it will return the person object with the Kevin Smith name. Else we print out that the optional is empty. So if I save and run it, in this case the optional is empty because as you can see we have specified a null value. But if we specify the person itself, if I save it and run it, this is a non-null object in the optional with value Kevin Smith. So with the help of the isPresent, we are able to check whether the person object is a valid object or a null object as we have specified earlier. We can use the so-called or else method. So we have the or else method. So if we create a new optional, for example, O is optional dot of nullable, and we create a new person with Peter Parker, for example, then we can get the person object based on the optional itself. So we can call this or else method. This or else is going to return the value if present, otherwise return another. So what does it mean? That if this optional stores a valid object, then we get the valid person with name Peter Parker, and otherwise we can define a new person object. So this is the new person object if Peter Parker is a null. If we print out the P, We just have to save it and run it. In this case, we print out Peter Parker because we have created an optional with a valid new person. But if it is a null, that what's going to happen, Java is going to check with the help of this or else method whether this optional stores a valid object or not. And because it is empty, because we have specified a null, the person is going to be the newly instantiated person. So in this case, just for demonstration purposes, this is the new person object. If Peter Parker is a null, we can specify, for example, Adam Smith in this case, and Adam Smith is going to be the person we are going to deal with. So this is why this or else is extremely powerful, because if a given person object is a null, then we can return with another one. We can create a new method, and if a given object is a null, then we can call that given method. So public static person give another person, and we return a new person with new person. It's going to be the name of the new person. Then here we can combine lambda expressions with optionals. That the person P is going to be the optional or else get, and we can call that given method. So in case the given option stores a null object, then we are going to call the give another person method, and then we print out the person itself. So because we specified a null, what's going to happen? The or else get method is going to return the value if present, otherwise invoke other and return the result of that invocation. So otherwise we call the give another person method, and we return with a new person. So the person is going to be this person, and we print out the person. So if I save it and run it, as you can see, the new person is going to be printed out. If it is not a null, but we instantiate a new person object, for example, Kevin Hart, then because Kevin Hart is not a null object, this is why this person is going to be this person we have specified here, and Kevin Hart is going to be printed out. So basically, these are the most important methods as far as optional is concerned. Thanks for watching. In this lecture, we are going to talk about how to handle optional with the help of map and flat map methods. So in order to demonstrate it, I'm going to create several classes. A person class, I'm going to have a passport class, so passport. I'm going to have a stamp class, so stamp. The stamp is going to have a private string stamp of country. It is going to have a constructor, so right click, source, generate constructors using fields. So this is a public stamp, it gets a stamp of country, and we set the stamp of country to be the stamp of country. And then we are going to generate the getters and setters accordingly for the stamp of country variable. So this is the stamp class. Of course, every passport has a stamp. So here we have a private stamp. Again, we generate the source and constructor. Without the super method call, we generate the getters and setters for the stamp itself. Okay, this is the passport class. And of course, every person has a private string name and a private passport. Again, I'm going to generate the constructor using the fields without the super method call, and I'm going to generate the getters and setters accordingly. So right click, source, generate getters and setters for the name and for the passport. So that's all about the classes. We have a person has a name and a passport, and every single passport has a stamp, basically the stamp of the given country. So first of all, in the main method, we can create a new stamp. So stamp is a new stamp. For example, the stamp of Barbados. We create a new passport. So passport is a new passport. Of course, we have to define the stamp itself. And finally, we can define a person. So person is a new person with name Kevin, and passport, the passport we have created earlier. Of course, if the stamp is not a null or the passport is not a null, then we can print out the person.get name plus the person.get passport.get stamp.get stamp of country, for example. And because we have defined all the stamps and the passports and the person name and all of these, of course it is going to work fine. But the problem is that there is a possibility that the stamp is a null or the passport is a null. So what do we have to do? We have to use a lot of if checks. So we check that if the person is not equals to a null, then we can get the passport. So a passport P is the person.get passport. If the P is not a null, then again we can get the stamp. So stamp S is the passport.get stamp. And if the stamp is not equals to a null, then finally we can print out that, for example, just for demonstration purposes, the stamp get stamp of country. So as you can see, it is not that convenient because we have to use a lot of if checks whether the given object is a null or not. And this is what we have been talking about in the previous lectures, that we should use optional. So this is why optional is an extremely powerful technique in Java, because we don't have to deal with null pointer exceptions. We don't have to check whether the given object is a null or not. So what do we have to do? The stamp class is going to be fine because it is just a simple string, the stamp of country. But the passport has a stamp field variable that may be a null. So what do we have to do? We have to use the optional like this as usual. So let's import the java.util.optional. Of course, the input is going to be an optional. The return value is going to be an optional. And here, the parameter is going to be an optional. So that's all about the passport. And why is it good? Because we don't have to check whether the stamp is a null or not, because Java is going to handle everything because of this optional wrapper clause. And we should do the same with the person clause. So instead of the passport, we should use optional passport, which means that first of all, we have to import java.util optional. Here we have to use an optional passport. Here we have to use an optional passport, and here as well. So this is how we make sure that we don't have to check whether the person's passport object is a null or not, because the optional wrapper clause is going to handle everything for us. Okay, the problem with this is that if we want to get the stamp of the country, so every single person has a passport, every single passport has a stamp, and every single stamp has a stamp of country, and if we would like to get this value, then we should use the lambda expression stamp of country is equals to, and first of all, let's handle the objects. Instead of a stamp, let's create an optional stamp with optional of nullable, and we have to instantiate a new stamp like this. Okay, this is what we have been talking about in the previous lecture. So we don't have to use this, and it is going to be just fine for the stamp. Why is it good? Again, because Java is going to handle null pointer exceptions. So if we specify a null instead of a new stamp, then the optional is going to be an empty optional, and there is no need to check whether there is a null pointer exception or not. We have to use the same with the passport. So passport optional like this, we have to use an optional.of nullable, and we have to instantiate a new passport like this. And finally, we have to use an optional with the person, optional of nullable, and the new person as usual. So this is how we create the optionals, and then we are able to use lambda expressions in order to get the stamp of the country based on the person, because every single person has a passport, as you can see, then every single passport has a stamp, and every single stamp has a string stamp of country. So we can use the map function, so map With the help of the map function, we can define what operation we want to do. So if you hover your mouse, if a value is present, then apply the provided mapping function. What do we want to do? First of all, we want to call the getPassport method within the person class. So the person class getPassport is going to return an optional passport. So this is what we want to do. Then we want to get the passport get stamp. So basically, with the help of this map, we are going to call the person get passport and then the passport get stamp method. And finally, the stamp get stamp of country method. We can use something like or else we print out unknown. So if this string is a null, then we are going to return an unknown, otherwise we get the stamp of the country. And the problem is that we get a compile time exception. So the type passport doesn't define get stamp optional passport. And the problem is that here we are dealing with optional. So we are not dealing with values. So not a stamp, but as you can see, the passport has an optional stamp. The stamp has a string, it is working fine. But for example, the person again doesn't have a passport, it has an optional passport. So in this case, we are not able to use the map method because it is resulted in a compile time error and we have to use a so-called flat map. So let's take a look at a concrete difference between the map and the flat map method. As far as map is concerned, if a value is present, applies the provided mapping function to it, and if the result is non-null, then returns an optional describing the result. What about flat map? If a value is present, it applies the provided optional bearing mapping function to it, returns that result, otherwise returns an empty optional. Its purpose is to apply the transformation function on the value of an optional, just like the map operation does, but then flatten the resulting multi-level optional into a single one. So this is the main difference between map and flat map. So this is the example we have considering. So the person.map, person get passport.map, passport get stamp.map, stamp get the stamp of the country. It results in a compile time error because the type passport doesn't define get stamp optional passport. So here we are not dealing with passport exclusively, but an optional of a passport. And the person get passport is going to result in an optional of a passport. As a result, the call to a get stamp is invalid because the outermost optional contains as its value another optional. So as you can see, an optional of a passport, which of course doesn't support the get stamp method. With the help of flat map, we can flatten the resulting multi-level optional into a single one. So the first flat map ensures that an optional password is returned instead of an optional password, and the second flat map achieves the same purpose to return an optional stamp. Note that the third call just needs to be a map because getCountry returns a string rather than an optional object. This is what we have been talking about, that for example the person has an optional stamp as an instance variable, but the stamp has a simple string variable. So this is why as far as the stamp is concerned, we can use the map method, but as far as person and passports are concerned, we have to use flat map because here we are dealing with an optional of a stamp. Okay, so a golden rule is that use map if the function returns the object you need, or flat map if the function returns an optional. Okay, so this is not going to work with map because it results in a compile time error. What we can do is we use flat map, and if we use flat map and flat map here, then it is going to work just fine, as you can see. So I'm going to use a system out println stamp of country. So if I save and run it, then it is going to work just fine. This is what we have defined here. If we want to use it for United States of America, then it is going to be the result. If we do not specify a given stamp, so it is a null, then because we use the or else method, then unknown is going to be printed out, of course, because the stamp is a null. But we don't have to deal with null checks and dealing with null pointer exception. This is exactly why we use optional. So if we run it like this, then unknown is going to be printed out. And this is why it is extremely powerful, as you can see, because we don't have to bother with null pointer exception. So this is how we use map and flat map. Thanks for watching. In the coming lectures, we are going to talk about Stream API. So first of all, what is a stream? Introduced in Java 8, the Stream API is used to process collections of objects. A stream is a sequence of objects that supports various methods which can be pipelined to produce the desired result. You can process data in a so-called declarative way, very similar to SQL statements. So what is this declarative way? It means that we can solve problems without requiring the programmer to specify an exact procedure to be followed. Stream lets the developer leverage multi-core architecture without the need to write any specific code. So it is extremely important that with the help of streams, we are able to do parallel programming very easily. What's crucial that a stream is not a data structure, instead it takes input from a collection, array or an input-output channel, and the stream provides an interface to a sequence set of values of a specific element type. However, streams don't actually store items, they are computed on demand. Operations performed on a stream doesn't modify its source. It's extremely crucial that, for example, filtering a stream obtained from a given collection produces a new stream without the filtered items, but this doesn't change the original source collection. So what's crucial that stream is a sequence of objects. It is not a data structure, so streams don't actually store items, they are computed on demand. It is extremely easy to do parallel programming with the help of streams, and stream doesn't modify its source. Okay, so let's take a look at the stream flowchart. We have a stream source that can be a collection, that can be an input-output channel or an array, so any kind of data structure. We can create a stream instance, and then we can do several intermediate operations, operation 1, operation n, so as many operations as we want, such as filtering, sorting, mapping, type conversion, and so on. And we can use a final terminal operation. As you can see, it is a single operation. So we can have as many intermediate operations as we want, but just a single terminal operation at the end. And with the help of the terminal operation, we get the result itself, such as a count, a sum, or a given collection. As far as intermediate operations are concerned, we are going to talk about filter, map, flat map, distinct, sorted, peek, and so on. As far as the terminal operation is concerned, we are going to talk about a lot of methods such as collect, count, reduce, for each, min, max, and so on. Let's take a look at a concrete example. We have a list of strings Alan, James, Kevin, and Joe, and we are able to filter this list of names as far as the first character is concerned. So as you can see, we can get the stream with the help of the stream method, so names.stream. Then we can filter the results. This is a single intermediate operation. And finally, we have the terminal operation that's going to collect the results into a list. Okay, so if we call for each on the names, of course we print out all the names, so Alan, James, Kevin, and Joe. But after the filter operation, the filtered names is going to contain James and Joe exclusively, because these are the names that starts with the capital J letter. So the stream is going to return a sequential stream considering collection as its source. The filter is going to use to select elements based on a specified criteria. The collect is going to return the result of the intermediate operations performed on the stream. What is the intermediate operation? In this case, we have just a single intermediate operation as far as filtering is concerned. Okay, so this is how we can get the stream, this is how we can perform an intermediate operation, and this is how we can perform a terminal operation. As usual, you can check Java API documentation if you want to check the exact methods as far as streams are concerned. Of course, in the coming lectures, we are going to talk about them on a one-by-one basis. Thanks for watching. In this lecture, we are going to talk about the fundamental basics of streams. So first of all, let's create a list of string. For example, the names. We can do something like this dot as list, and here we can specify the values. So Adam, Kevin, Joe, Alan, Natalie. These are going to be the values. Of course, we have to import the list interface, so java.util.list. Okay, so we can use streams with the help of the stream method. So first of all, we are going to end up with a list of strings. It is the filtered names. It is equals to the names dot stream. So with the help of the stream method, we can get a sequential stream with this collection as its source. So we are going to use a stream based on the names list of strings. So these are the values we are going to manipulate with the help of a stream. And we can use an intermediate operation such as filter. In this case, we would like to make sure that we keep the names where the name starts with, for example, capital A. And finally, what do we want to do? We want to collect to a collector dot to list. So this is exactly what we want. Of course, because collectors, sorry for that. So collectors is java.util.stream.collectors. And with the help of this intermediate operation, Java is going to select the names that starts with a capital A. And finally, in the terminal operation, Java is going to collect the results into a list. And this is why list of string is going to be the type of the result. So what do we have to do? We can do something like this: filtered names dot for each system dot out println. This is what we have been talking about. This is the method reference itself. We can call system out println method on every single filtered name that are stored in the filtered names list. So if I save it and run it, then Adam and Alan are going to be the results. Of course, if we change the criteria, so I would like to start with letter Z, then the result list is going to be empty, of course. If I want to make sure that the first letter is going to be an N, then Natalie is going to be in the result list. So this is the intermediate operation, and this is the terminal operation. Let's try to modify the terminal operation. We don't have to collect the results into a list of strings. We can use something like we filter the names based on the first character, for example, starting with letter A, and here we call for each. And again, we can use method reference, so system.out and println. And in this case, we are going to get the list of strings, so the original data structure. We are going to call the stream method. We are going to filter and select the ones that starting with letter A, and then we print out the values. So in this case, the result is going to be Adam and Alan. Okay, if we do not print out the values, then we can store this result as a stream. So stream of strings, it's going to be the stream. And as you can see, it is going to work fine. Of course, we have to import java.util.stream, but as you can see, if we call the stream method and then we do some intermediate operation, then the result is going to be a stream of strings. Why strings? Because the original data structure we are manipulating is a list of strings. So this is how we can store the stream itself, and then we can call the stream.forEach, and we can call the system.out and println. So what's crucial that we are able to store the stream itself, and then we are able to do further operations. So the result is going to be the same, of course. So that's all about the fundamental basics of streams. Thanks for watching. In this lecture, we are going to talk about the most important methods as far as streams are concerned. So first of all, we are going to talk about the stream.origin of method. Of course, first of all, we have to import java.util.stream. And we would like to call the static method of. So it is going to return a sequential stream containing a single element, but we can define several items as well. So this is item 1, then we have item 2, then we have item 3. And we can do further operations. For example, we can find the first one, and if it is present, then we are going to call the system out println method. So if I save it and run it, of course the first item is going to be printed out. So what's crucial that with the help of this of method, we are able to create a given stream containing the given items. In this case strings, but we can use integers as well. So in this case the stream is going to contain integers and the first item is the value 10. So this is how we can use the of method. Let's talk about the filter and count methods. So I'm going to create a list of strings, for example arrays.asList, and here we can specify the given values. So Alan, Adam, Kevin, Joe, and James. So these are going to be the values of the list. Of course, we have to import java.util.list. And we can use streams again. So we can get the stream. So as you can see, in this case, we are going to transform the names, which is a list, into a stream. So this stream returns a sequential stream with the collection as its source. And then we are able to filter. So we would like to call the filter method because we would like to make sure that we store the names that starts with, for example, capital J. And then we would like to count the number of names starting with capital J. The result is going to be a long, but I'm going to print it out. So let's use something like this. So if I save and run it, the result is going to be 2 because there are 2 names starting with capital J. Let's print out the count of the names starting with K. Of course, they're just the single name starting with capital K, so that's why the result is going to be 1. So we can filter the given stream, and finally we can use the count operation that's going to return the count of items in the stream with this given constraint. Okay, so this is how we filter, and this is how we use the count method as well. We can use the so-called iterate method. So we are going to create a stream of integers, numbers. It is a stream.iterate, and here we can define that we start with 1, and the formula is going to be n equals to n plus 1. So what does it mean? That we are going to increment the value by 1. And then we are going to limit to 10. What does it mean? That we are after the first 10 items. So we can do something like this, that numbers for each, we print out the given number. So system out println n and plus some spacing. I'm not going to use a new line character, so something like this. So what's crucial, as you can see, that first of all, we are able to get a given stream, and we are able to iterate through the stream with the help of a for each loop. And because of this iterate, let's save and let's check the solution. As you can see, we start with 1, and this is the formula we are going to use. If we use something like this, that n plus 5, then what's going to be the result? We start with this value and we keep incrementing the values by 5. So that's why 1, 6, 11, 16, 21, and so on. So the limit is going to limit the number of integers we are going to get in the end. So as you can see, in this case, we have 5 results. If we use, for example, 20, then there are going to be 20 integers. So this is what we can do with the help of the iterate method. We are able to generate random numbers, so the result is going to be a stream of doubles, and we can use the stream.generate. We are going to use the math.random method, and again we are going to use the limit because we are after the first 5 random doubles. So then we are able to iterate through, and I'm going to call the system.out and println. So I would like to use a new line character. So what does it mean? That we are going to end up with 5 random values, because the stream.generate is going to return an infinite sequential unordered stream where each element is generated by the provided supplier. And the supplier is the random method that going to return a double value with a positive sign greater than or equal to 0 and less than 1. So basically this generate is going to use this method in order to generate 5 random values. If we set the limit to be 10, then of course we are going to get 10 random numbers within the range 0 and 1. So this generate method is going to use this provider as an underlying implementation, and in this case we generate 10 random numbers. Let's talk about the reduce method. So I'm going to create a string of title is equals to this is just an example. So we use a one-dimensional array of strings, and we can use the so-called reduce method. Of course, if we want to use streams, then first we have to transform this one-dimensional array to a stream. So stream is a new arrays.stream, and we have to provide the title. So this is how we transform the one-dimensional array of strings into a stream of strings. And then I'm going to use an optional and string the result, which is equals to the stream.reduce. And here we can define a given operation, that word1 and word2, and the result is going to be the word1 plus some concatenation word2. Okay, and finally, let's print out the result. Of course, we have to import java.util.optional. So first of all, let's run it, and then let's talk about the result. Of course, we can call the get method that's going to return just the string without the optional, as you can see. So if I run it, this is just an example. So what has happened? We have the original one-dimensional array of strings, and we would like to concatenate it with the help of a dash. And we can do it with the help of reduce. The reduce performs a reduction on the elements of the stream using an associative accumulation function and returns an optional describing the reduced value, if any. So in this case, we are going to tell Java that, okay, take any of the two words right next to each other and let's concatenate it by a dash. And if we use, for example, a plus sign, then of course it is going to be used, as you can see, the plus sign. What's crucial that in this case the result is a single string, so a single value. As you can see, we take several inputs, basically a one-dimensional array of distinct strings, and with the help of the reduce method we are able to end up with a single string. So this is the most important feature of reduce, that it is going to reduce several values to a single value. Okay, let's talk about the map method. For example, we have a list of strings, words. We use arrays as list as usual. This is again an example. So this is what we are going to transform to a stream. So first we have to get the stream. Then we have to call the map method, and the map method is going to transform the strings to uppercases, and then we are going to collect the words into a collectors.toList. So what does it mean exactly? First of all, the map is going to return a stream consisting of the results of applying the given function to the elements of the stream. So if we define something like this, that the string to uppercase, then Java is going to consider all these strings and going to apply the to uppercase method, and then we are going to collect the results into a list. Of course, we can use for each, and I would like to print out, so println. So in this case, we iterate through the list and print out the values accordingly. So if I save it and run it, as you can see, this is again an example. To uppercase is going to transform all the letters to uppercase characters. So the map method is going to apply this operation on every single item we have defined. Okay, and let's talk about flat map. For example, we have a list of strings, female names, arrays as list, and here we define Kate, Judy, and Nicole. We do approximately the same but with male names. So arrays dot as list and Kevin, Peter, and Joe. Then we are going to combine these lists. So we have a list of strings, the names for example, arrays as list, and we have to define the female names and the male names as well. So Java is going to combine and going to create a list of lists. So if I print out these names, then let's take a look at the topology of the list of lists. As you can see, we have the first list with the female names and we have the second list with the male names, and as you can see, it is a list itself. So the list has two items, the first item and the second item, and the first item is a list itself with the female names, and the second item of the list is a list itself with the male names. So in this case, when we have a list of lists, this is when we are not able to use map, we have to use flat map. So we have names, we get the stream, and if we want to use map and we want to transform the inner lists to a list of stream, and then we want to collect to a collectors.toList. So basically, what do we want to do? We want to merge these lists and we want to end up with just a single list with all the names, whether it is female name or male name. So this is what we want to do. But in this case, if I do something like this and for each system out println, then let's check what's going to happen. I save it and run it, and as you can see, this is not what we are after. We would like to end up with a single list that contains all the names, no matter the given name is a female name or a male name. So this is why we have to use flat map. If we use flat map, then Java is going to take the lists on a one-by-one basis, and the result is going to be Kate, Judy, Nicole, Kevin, Peter, and Joe. So this is what we can do with the help of a flat map. If we have a list of strings, then we can use flat map as we have seen in this example. So basically these are the most crucial methods as far as streams are concerned. Of course, in the coming lectures we are going to consider further operations. Thanks for watching. In this lecture, we are going to talk about how to use streams as far as maps and hash maps are concerned. So first of all, let's create a hash map. So a map with integer keys and string values, it is going to be the map is a new hash map. So let's instantiate it as a hash map, and of course we have to import java.util.map. Then I'm going to use map.put a given integer and a value. For example, 1 is the name Kevin. Then I'm going to put several other names as well. So we have 2, 3, 4, and 5. We have Joe, we have Adam, we have Judy, we have Donald, and we are able to use streams as usual with collections. So the result is going to be an integer and string related map as well. It is the result map. We can do something like this, that map, we have to call the entry set method, and then we can call the stream method. And now we are going to call filter, and we are able to filter our data structure. For example, we want to make sure that the map key value is smaller or equal to 4, for example. And then we want to collect it to a collectors.toMap, and we have to define the map.entry get key and map dot entry get value. So the getters as far as the key is concerned and the value is concerned. So if you hover your mouse to map, then it returns a collector that accumulates elements into map whose keys and values are the results of applying the provided mapping functions to the input elements. So this is why we have to define the get key and the get value. Okay, and sorry for that, we are not able to use the map because we have already used that variable. Let's use the letter M just for demonstration purposes. And if we print out the result map, so let's save and run it. As you can see, the result is Kevin, Joe, Adam, and Judy, because as you can see, the key values are smaller or equals to 4. So 1, 2, 3, 4. So this is how we can filter a given hash map. We can use something like the skip method. So if we want to skip the first 2 items, it means that Kevin and Joe are not going to be printed out. So as you can see, the result is Adam and Judy because, okay, the key values are smaller than 4, so Joe and Kevin are fine, but we skip the first 2 items. If we skip just the first item, then Kevin is not going to be printed out, but Joe, Adam, and Judy are going to be printed out. If we use something like it is smaller or equals to 5, then all the items are going to be printed out except for the first one because we skipped the first item. Okay, so this is how we can use a stream as far as a hash map is concerned. As you can see, we can call the stream method on the entry set, and then we can use any methods we want. Filter method, skip method. Finally, we can collect the results into a map of integers and strings. So this is how we can use streams with hash maps. Thanks for watching. In the coming lectures, we are going to talk about the difference between sequential streams and parallel streams. So first of all, what is parallel stream? The Stream API enables developers to create the parallel streams that can take advantage of multi-core architectures and enhance the performance of Java code. In a parallel stream, the operations are executed alongside each other, and there are 2 ways to create a parallel stream. On a collection, we can use parallel stream method. On a stream, we can use the parallel method. Use parallel streams only with stateless, associative, and non-interfering operations. A stateless operation is an operation in which the state of an item doesn't affect another item. An associative operation is an operation in which the result is not affected by the order of operands. And a non-interfering operation is an operation in which data source is not affected. So what's extremely crucial that of course we have to make sure that the given operations are totally independent of each other. This is when we can use parallelization. Otherwise, the operations have to wait for each other to finish because they are depending on each other. I'm not sure whether you are familiar with algorithms, but for example, merge sort or quick sort can be parallelized because the sub-procedures are totally independent of each other. But for example, solving differential equation cannot be solved with parallel algorithms because the next step and the next calculation depends on the actual one. So we are not able to parallelize the given algorithm. So what's crucial that there are algorithms that can be parallelized and there are algorithms that are inherently sequential. So we use parallel streams only with stateless, associative, and non-interfering operations. So as far as sequential processing is concerned, this is the case when we have just a single processor or a single processor core. Basically, it is very similar to an iteration. So the first task is going to be executed first, then the second one, then the third one, and so on. So in a sequential manner. If we have multiple processors or multiple processor cores, then we can use parallelization, which means that every single processor have different tasks to execute, and iteration 2 is independent from iteration 1 and iteration 3 and iteration 6, and these tasks are totally independent of each other, so we can assign these tasks to different processor cores. Of course, if the iteration 2 depends on iteration 1, then we are not able to use parallelization because we are not able to solve iteration 2 because it depends inherently on iteration 1. So it is crucial to know whether a given problem can be parallelized or not, but this is the crucial difference between sequential execution and parallel execution. So you may pose the question when to use parallel streams. You need to consider parallel streams if and only if you have a large data set to process, you are actually suffering from performance issues, and you need to make sure that all the shared resources between threads are synchronized properly, otherwise it might produce unexpected results. So in the next lecture we are going to take a look at a concrete example, what is the difference between sequential streams and parallel streams. Thanks for watching. In this lecture, we are going to see the difference between sequential and parallel streams. So for example, we would like to measure the time, so that's why we get a long start, which is the system.current time millis. Then I would like to create a long c, which is an integer stream, so java.util.stream.integer stream. And I would like to call the range close method that returns a sequential ordered integer stream from start inclusive to end inclusive by an incremental step of 1. So starting with 0 up to 1 billion, then I would like to filter, and I is the I modulo 2 is equals to 0. What does it mean? That I would like to filter out the even numbers. So this is the so-called modulo operator, which means that if we divide the given integer by 2, then the remainder is equals to 0, which means that the given number is even, and I would like to count the number of even values. Okay, and this is the operation we are going to measure. So we have the duration, which is system.current time millis minus the start, and then I would like to print out counted the c variable and in plus the duration milliseconds. So if we use a sequential stream, if we run it, then it is going to take a while to count the number of even values, 1500 milliseconds. What if we would like to use parallelization? Then we can call the parallel method, and then we would like to call the filter. So with the help of this parallel method, it returns an equivalent stream that is parallel. So let's try to memorize that the sequential result was 1500 milliseconds. What about the parallel solution? As you can see, it is approximately 500 milliseconds. So what does it mean? That using parallelization can be extremely powerful if the data set is huge. In this case, we have a billion values, so we have a huge data set we want to filter, so it is definitely a good idea to use parallelization. But if we have, for example, just 10 items, then using parallelization is not going to be faster than the sequential approach. In this case, it is 50 milliseconds, and if we do not use parallelization, then I guess it is going to be faster. So as you can see, using sequential approach is faster than using parallelization. If we rerun the application, it may be even faster. Okay, so this is the crucial difference between sequential streams and parallel streams. With the help of parallelization, we can take advantage of multiple processors or multiple processor cores. Thanks for watching.